So now we get to the last objective of chapter 3, and I know chapter 3 has been long, but honestly, I think this is the most important thing that we're going to learn in chapter 3. And this is we're going to look at covariance and correlation. So first of all, the covariance is looking at the relationship between two variables. So we're going to do it using that growth and value fund that we've been looking at to see, is it linear? And if it is linear, is it a positive relationship, a negative relationship, or no linear relationship at all? So when we talk about the covariance of a sample, notice that we use S. S is commonly used for standard deviation, so don't let that confuse you. When it's S subscript XY, that means it's looking at the X variables and the Y variables. So that makes it a covariance as opposed to just when we look at just SX or just XY, which makes it a standard deviation. So a good idea might be to start yourself kind of a little cheat sheet over to the side where you can have all these formulas written out. Now, just like with the sample for the population, we use that little funky little O looking thing, which remember is the Greek letter sigma. That's the lowercase sigma. Also, we use sigma for standard deviation of a population, but that's when it's just sigma subscript X or perhaps sigma subscript Y. So when it's sigma subscript X and Y together, that makes it a covariance. So don't let that confuse you. So the formula of the covariance is we're going to take each observation in the X variable, subtract it from the mean, or subtract the mean from it, then do the same thing for the Y variables, multiply those together, add them all up. Then we divide by N, which is the number of items in the sample, minus 1. Okay. Now, if we're looking at the population covariance, it's the same formula, except remember we're using mu for our mean. And then our denominator is the capital N, which is the entire population, the number of items in the entire population, and we don't subtract 1 from it. So if we go look at our growth and value funds, we're going to call the growth the X fund and the Y, the value, the Y fund, sorry. Now back in chapter 2, we looked at a scatter plot. And so if we just looked at a scatter plot here, we've got these plotted, we can see, all right, this appears to be a fairly linear relationship. We're kind of eyeballing it here to see that it's a linear relationship, but we can actually calculate that using that covariance. So if we go back to our data, we've got each of the observations in the X fund and each of the observations of the Y fund. We're going to subtract each of those from the mean. Remember from our earlier calculations, the mean of the X fund was 10.09 and the mean of the Y fund or the value fund was 7.56. So we're going to get all of those calculated, multiplied together. Remember our order of operations. We're going to do what's in the parentheses first, then multiply together, and then we add them all up. So now we'll divide by 10 minus 1. Now notice there's 10 observations in both the value fund and in the growth fund. We're not adding them together to say the entire sample is 20, right? The entire sample is 10 because there's 10 observations in each fund. So we get a positive number of 350.44. That tells us that the growth fund and the value fund have a positive linear relationship. If we had gotten a negative number, we would say they have a negative linear relationship. And if it had been 0, then we would have said, well, there's no linear relationship whatsoever. Now, 350 is a pretty big number, so we might be tempted to surmise that this is very strongly related, but we got to be careful with that. With covariance, we cannot make any sort of interpretation about the strength of the relationship. We can only determine the direction. So this is a positive direction, a positive linear relationship. If we had calculated 1 and we got 30, we couldn't say that this positive relationship is stronger than another one. We can't determine strength. We can just determine directionality. So covariance has some limited uses. We can say, okay, yeah, they're positively related, but that doesn't necessarily mean that, we don't know how positively related, how correlated are they. So that's where we get into the correlation. So the correlation coefficient is looking at both the direction and the strength of the linear relationship. So for the sample, we're going to call that R, subscript XY. And then for the population, I know that looks like a P, but that's really the Greek letter rho, R-H-O, pronounced rho, even though it looks like a P. So we're going to use rho for the population and R for the sample to calculate the correlation coefficient. So the formula for the sample correlation coefficient is just, notice your numerator is that SXY, that's the covariance that we just calculated, divided by, now this X is the standard deviation. So it's divided by the standard deviation for the X variables multiplied by the standard deviation for the Y variables, okay? So remember, when it's S with just one variable, it's standard deviation. When it's S with two variables, it is the covariance. So our options here are only going to be, our answers will only fall between -1 and +1. So if you calculate this and you get a number that is greater than 1 or less than -1, you know you've made a mistake somewhere. Because -1 is your minimum amount, +1 is your maximum amount. So a coefficient of exactly +1 means these are positively related, and it's a one-to-one relationship. They are directly related. As one increases, the other increases by the exact same amount. A correlation coefficient of -1 means they are negatively related but in a one-to-one relationship. It's a direct negative relationship. And then of course if we get 0, it means there's no relationship whatsoever. So now we can determine strength because we can say the larger the number, the closer to 1, the stronger the relationship, or the less to 1, the less relationship they have, or the more negative the relationship that they have. So for the population, we're going to calculate it exactly the same way. Notice that our numerator is the covariance for the population. Our denominator is the standard deviation of the X multiplied by the standard deviation of the Y. So again, those mean exactly the same thing. So going back to our data, so this is what we calculated before. This was the covariance of the growth and value funds. And so now we can plug these into our formula to calculate the correlation coefficient. So if you remember, and we're going to look at this in Excel in just a minute, the standard deviation for the growth fund was 20.45 and the standard deviation for the value fund was 18.46. So when we divide that out, we get 0.93, which is a very strong correlation. So they are positively related. It's not a true one-to-one relationship, but they are very positively related. So now let's jump over to our Excel and look at that data again. So I'm back here in our growth value fund. This is what we've been working in so far. And we want to go ahead and calculate the covariance and the correlation coefficient for both of these. So let's just jump down here. I'm going to go ahead and add covariance. Now, remember, the covariance is for both the growth and the value fund. And since we already have those in rows, we're going to treat growth as the X variable and value as the Y variable. So again, I can go up here to more functions, statistical, and I can find the covariance. I also put it there. It's there in your notes on page 60, or in the book on page 68, and at the end of the PowerPoints. So for the covariance for the sample, I'm just going to go ahead and type it in since I know what it is. It's equal, and then COVAR. Now notice again, it starts populating here. We get covariance.P, that's covariance for the population, or covariance.S, which is covariance for the sample. I want covariance for the sample. So then it asks me, what is my array 1, which is going to be my growth fund, my X value, and then I'm going to put a comma, and my array 2 is my Y variable or my value fund. And then I'm going to close my parentheses and I'm going to press the check mark here. And notice we get 350.44, which is what we got earlier. Now I can also go in here and calculate the correlation coefficient. Now, we can type it in just by saying equals and then type in the formula, but I'm going to go up here and use the statistical formula that's built in here for me. So the correlation is this CORREL. So again, when I open this up, it's going to ask me again, what's my, let me fix that. So that's my array 1, and then I'm going to click the box for my array 2, and this is my value fund, and I'm going to click OK, and here it gives me 0.928, which rounds to 0.93. So we've got our correlation coefficient calculated as well, and we can see that again these are very positively and strongly correlated.